Okay, here's a problem for you to try. So go ahead and jot that down and try it. And I'm going to work it out for you. So I'm going to follow the steps. I'm going to change g of x to a y. And then I'm going to interchange all the x's and y's, which means all the y's become x's, all the x's become y's. So we'll have x equals 1 over y plus 1. Now I need to solve for y. Well, I have one term that has a fraction, so I'm going to multiply each term to clear that fraction. So I'm going to multiply each term by y. That's going to give me xy equals 1 plus y. Now we still want to collect all the y terms on one side of the equation, and we want everything else to be on the opposite side. So I'm going to subtract y from both sides. That's going to give me xy minus y equals 1. I'm going to factor out a y. I factor out that y, and now I can solve for y by dividing both sides by x minus 1. And my answer in function notation, the function's name was g. So it's a pretty loud plane. It's actually not a plane, I believe it's a jet. I'm going to rewrite y with function notation, and because it's the inverse, I'm going to put g inverse of x is equal to 1 over x minus 1. And that is our inverse function for g of x. Now, inverse functions can be pretty algebraic intense, so I encourage you to get all the practice that you can in finding inverse functions. We'll talk about what their graphs look like. Their graphs are pretty cool. Their graphs are symmetric about the line of y equals x. So should you ever graph a function and its inverse function on the same grid, you'll see that it's very much symmetric. We're going to touch on that when we'll go into it pretty deeply when we graph exponential and logarithmic functions. Exponential and logarithmic functions.